Hi, hello everyone. Welcome to this session on declarative clients in Spring. I will tell you a bit about the solutions that we have had so far in this area, and then about a brand new solution that has become available with Spring 6. I'm a software engineer in the Spring Cloud team. I maintain the Spring Cloud load balancer and Spring Cloud OpenFeign, Spring Cloud Square. I also work on Spring Cloud Contract, and I have been working on the native integration and the AOT support for the Spring Cloud projects. And regarding what Cora and Dashon have said, I can tell you that starting with the RC2 that we are going to release probably today, there will be already native support for Spring Cloud Gateway, and we already have native and AOT support for the discovery clients, for config client, for load balancer. Yeah, and we'll be adding it also for OpenFeign. So what is a declarative client? Let's imagine a scenario where we have two applications. So we have a certain customer service where our customers can register, but we do not entirely trust them. We think a small part of them can be frauds, so we need to verify if they're legit, and we are dividing our responsibilities, so we create a different microservice, the verification service, to check it. And we will be running HTTP posts at the verify endpoint, and we will be expecting to get a customer verification result. So there are many ways of doing it. Some are better, and some are worse. So the one which is easiest and probably the worst is just we have our business class, we suddenly realize we need some information from a different microservice, we inject a client, a REST template, a web client, whatever, we do our call, we get the info, and we go on, we are happy. This works. This is probably not the most readable or best solution. We can then start improving our solution and probably create an interface, and there add all the methods that we would be calling against that different service, because probably there are also other endpoints that we might want to be calling. Then we will be able to reuse these methods, we will know our return types, we will know our parameters, and then we can have some implementation class just for that service, only taking care of that client communication. And we can have even various implementations thanks to this approach. So we could have a REST client, web client and some environment, and then use a different profile and use REST template in a different environment. We could do different setups. And also having this kind of interface and implementations allows us to have all the common concerns or the setup that we typically repeat, extracted into some kind of reusable components. For example, if we often set same kind of headers or do similar things when it comes to processing our URI path. And then we obviously just call this whichever method we want from the methods that we have added on that client, and then we can process the result. Let's imagine what would be there if we could only have this interface. So basically, no implementation, just the interface plus some kind of annotations similar to the ones we use in controllers to indicate what the elements of our HTTP calls would be. That solution would have an interface that would be defined by the user, and with the method calls annotated with all the required parameters. And then the framework or the library underneath would create a proxy that would handle the actual HTTP calls for us. So the user only creates the interface. And as many of you may know, there are already these kind of solutions available. Feign is a vastly popular solution, and this is what this interface looks like. Feign has its own annotation, so the request line annotation is typical for Feign, and it can allow you to indicate the method and the path with any segments where you want to pass parameters. Then you can use the param annotation to indicate what parameters it will be, and then you can call the method in your code. Feign was primarily part of the Spring Cloud Netflix module, but later was extracted and passed over to the community. It is now maintained as a third-party project. It supports various HTTP clients, including Apache HTTP, Apache HC5, OK HTTP. And what's very important, it has a concept of contracts that allows the library creators and other developers to add support for their own annotation. And it also has a very broad range of encoders and decoders, including for Jackson and JSON. It has metrics, and for quite some time now, it has supported micrometer. And there is also Spring Cloud OpenFeign, which is how a lot of people consume Feign. So this is a project that Spring Cloud has built around the core Feign solution, and it provides easy-to-go integrations with other Spring Cloud projects. So it provides load balancing integration, it provides circuit breaker integration, it provides tracing support. Most importantly, it adds Spring MVC-style annotations to the Feign annotations. So instead of using this request line as in Feign, you use get mapping, and then you use request header and request param, and you can basically copy-paste what you have in your Spring controller annotated with Spring MVC-style annotations. Just remove the method bodies, and you end up with the signatures, and that's going to work with Spring Cloud OpenFeign. And then we also provide a starter, which means we do all the auto configuration for you and just create all the necessary beans and all the child contexts for load balancing. So I will show you a demo, but you don't need to do very much to make it work. So this is a Spring Cloud OpenFeign interface doing exactly the same thing, but this time using this Spring-specific annotations, and we also have Feign client where we pass the service ID. This will allow us to load balance based on the service ID, and this will also trigger the beans creation for this client. And then, obviously, we need to call it somehow, and this is how you will do it, same as with the previous implementations, but you didn't have to actually write this HTTP calls. So let's see a short demo. In the demo, we'll see these two applications, and in the meantime, in the middle, we would imagine that there would be some kind of service registry. So for demo purposes, I'm just going to use a properties file and list our instances there. Many people do not know. It's one of the questions that I get a lot at Stack Overflow is what to do if you don't have service registry, or for your test. We actually have a simple discovery client, so you just use the instances for every service in the properties file. I do not particularly recommend this approach in production, but if you need something like this, it can be done, so that's what we will do. We will have load balancing added by default, and we will have Spring Cloud Sleuth, and this is going to be the only demo I will show against Spring Cloud 2021 that works based on Spring 5. Why? Because for now, here we have this Spring Cloud Sleuth library, but starting with Spring 6, this library will no longer be there, and the instrumentation will be done directly in the projects. It will also be done in OpenFeign. However, we have a slightly different release cycle. Our GA is not until December, so this is still being developed. It will be there. And the other demos that I will show will already be based on Spring 6. So let's take a look at this. Okay, first our verification service. It's a very simple Spring Boot app, and it just has a controller, and you can just post something at this endpoint, and you will get some sort of result. We will not do anything more with this because it is not very interesting. It just responds. But what we have in the other service, we have the starter for OpenFeign, and for load balancer, and for Sleuth, which will not be anymore needed, starting with Spring Cloud 2022. And this will set up a lot of things for us. We have our simple discovery client. So these are the instances that will be used for load balancing. For this demo one instance, we could have a whole list, or much better, we could just connect to a service registry like Eureka for doing this. And then The entry point of this application will be this controller, where we will just run a request through the command line, and we will ask them to register a customer. And as we see, this will redirect us to this method that we have seen in slides. Later in the demo, you can uncomment the rest of the code to see the previous implementations that we've seen on slides. This is the OpenFeign client that we are going to do the calls with. And this is our actual interface. So that's pretty much all. I don't need to do any other setup for this to work. So I'm just going to run these applications. Okay. And then we can generate some posts, and as you see, they are passing. If somebody's wondering what we are posting with, it's a super simple person object that we have created a JSON for. We don't need this. Okay. So, yeah. And not collaborating with me. Anyway. So as you can see, the load balancing was done under the hood just by adding the starter. The call was done without you having to do anything explicitly, just using this interface. And you got tracing information, so trace IDs, span IDs added just based on that starter. And yeah, going back to the presentation. It is a highly popular solution. So as you can see, many GitHub stars, and the number that I've put here are just Maven downloads only in 2021. Why is that? It is because it has nearly flat learning curve for any Spring MVC users, because you can basically copy-paste the method signatures and all the annotations, and it works out of the box. However, it also has its issues. So first of all, the decision to allow the request mappings and the server-style mapping annotations to be used on the client side has brought some issues. People, for example, use the same interface to implement it and then use it also as a controller, or place this request mapping annotation over the class in the client, because that's what they could do also on the server side. And this has caused issues, and this has even caused CVEs. And we have discouraged using it, and then after the CVE, we finally have disallowed using this. And another problem that we have with Spring Cloud OpenFeign is that as it relies on a third-party component in its core and only provides integrations, and many times we had some issues that we couldn't solve for a long time because we had to wait for some changes in the actual core Feign project that has a super nice community, but also not a lot of maintainers, so it takes some time. But even though we had these issues, we still would be recommending this as our primary solution because it's great in many ways. However, what made us reach the decision that we needed something else was the lack of non-blocking support. Unfortunately, we were not able to add it because to add this, the entire Feign core project would have to be re-architected, not only our integration. So it was a big blocker for us. So we tried to find a way around it. And we have thought that we could provide the same kind of integrations and support for retrofit, which is a similar kind of interface declarative client provided by Square. And we have, in fact, created a Spring Cloud Square project that provides this integration. So load balancing integration and tracing integrations for retrofit clients, and also allows using web client under the hood for retrofit, and provides non-blocking communications. So we have also provided auto configurations for that, and we have created it as an incubator project. I'm going to show you what this interface looks like, just so you can see some code. So yeah, as you see, it is very similar, just the annotations are different. And given the issues that we had with allowing to use the Spring MVC annotations in Spring Cloud OpenFeign for Spring Cloud Square, we decided to allow using only the retrofit annotations, but then we also provided the retrofit client annotation on top, which will allow us to handle the load balancing and the bin creation. There has been also more stuff happening in the declarative clients or interface client space. Our colleague, Josh Long, that many of you know, has created an interface client for our socket called RetroSocket and has added it as an incubator project. And when it comes to Spring Cloud Square, that's also an incubator project, but we have already released some versions. So we have 0.4.1 released. We will release at least one more version, and we will maintain it until Spring Cloud 2021 is maintained. And for Spring Cloud 2021, this is the recommended solution for non-blocking interface clients. So if you're still running applications against Spring 5 and Spring Cloud 2021. And however, we were not sure what to do starting with Spring 6. And we thought, we have this OpenFeign support, which is great, but unfortunately no blocking support. And then we have the new Spring Cloud Square projects, which is just in the incubator, so not many people are using it still, but maybe we want to popularize it. Then we have the RSocket client, the Josh's project, that we want to popularize as well. And we thought in the Spring Cloud team, maybe let's move them all to one big project, make it in one repo, and just call it interface clients or declarative clients or whatever. But in the Spring Cloud team, and in Spring team in general, if you want to move any projects out of the incubator, you have to talk with the broader team, and you have to have everyone on board. So we have done just that. And we have proposed this, and this has actually triggered a larger discussion about interface clients in Spring. And actually, Spring had already a remoting package that is now being removed in Spring 6 because it supports outdated protocols. So the protocols are outdated, not really used, but the pattern is the same. You provide an interface, and the library provides a proxy and handles the communication. This was symmetrical, so you could also implement this on the server level. And this was a pattern that we already knew. Also, Spring Framework has actually started to think independently about creating RSocket interface client. An issue was created, and the plan was there. And previously, Spring users have requested us to create our own interface client, similar to Feign or similar to Retrofit, within Spring. And this issue was opened in 2014, and it was closed, and because it was deferred to, wait for it, Spring Cloud OpenFeign. So they said, we already have a solution that is perfect, people are using it, it is providing all the necessary integrations, so we don't need to have it in-house. But this situation changed when the non-blocking support was required to have consistency with the other projects and the other patterns that we provided within the portfolio. And this gave us the opportunity to revisit whether we really need to have these projects in Spring Cloud. Because if we think about this, the mechanism of the integrations that we provide is not this mechanism that is in the core of the interface clients, Feign or Retrofit, is not specific in Spring Cloud. In Spring Cloud, we just provide integrations and features and extensions on top of these solutions. So maybe we could have this solution, the central one, in Spring Framework instead, and then again use Spring Cloud to provide all the integrations and the load balancing and the other features that we provide. Also, we thought that certain things, like rethinking the programming model, could not be really done in Spring Cloud. If we want to work with annotations, we should do this in Spring. That's the right place for it, where other annotations live. So we decided to explore the possibility of adding it for Spring Framework 6. We have created a small intra-team and we have started working on it. And I would like to take you a bit through the thought process that we had while working on it. First, we started to think, should we reuse the request mapping annotation also on the client? What should be the relation with the server-side annotations? And While in server side, we want to use wildcards and we want to be very open, which we will see in an example in a moment. For client side, we need to define a single request, and we cannot really allow wildcards. We can allow templates, but not wildcards. And also, we didn't want to have this situation where we would have very server-specific things on the client side, or like tell people that, okay, you can use this request mapping annotations as you were using it on server side, but do not use this parameter, do not use that annotation, and do not use that attribute. This would create confusion. So to avoid these kind of situations and to avoid having to handle wildcard situations, like in this example, where we can have any HTTP method and any URL path will match, and we can be mapping of elements from 1 to n, we didn't want to do this. And we also didn't want to support the annotated parameters that didn't make sense for client. So in request mapping, some of them made total sense. Like if you look at request header or request param or HTTP method, even if you read the Java docs, it can be used same on both server side and client side without having to change even the Java doc. They just work perfectly. But some are super server specific. For example, servlet request or servlet response or model attribute wouldn't make sense for the client. You might think that request attribute also wouldn't make that much sense for the client. However, we did use it before with web client, for example, to provide hints for Spring security on which authentication type to use. Similarly, with return values, some would make sense on both sides, response entity, HTTP headers, or body, or void. But when it comes to view, or model, or SSE emitter, we didn't want to have this supported in any way in our interface client. So request mapping annotation cannot be used on the client side. We have added a new annotation called HTTP exchange. And you can pass the following attributes: the URL, the method for your exchange, and then content type and accept, which works kind of similar to consumes and produces, just on the reverse. And then when it comes to the method parameters, we are using the subset of those from request mappings, but only those that make sense for us. So we are also not reinventing the wheel. If something worked and made sense, we added it. So those are the ones that we currently support. You can see, obviously, the request headers, path variables, request body, and request params. If it's a data form, it will be used in the body. Otherwise, it will be used to create the path segments. And yeah, we also allow you to override as a method parameter the URI, if you pass a URI, or if we recognize an object as an HTTP method, you can also override the setup through the parameter. And then when it comes to return value, again, it's a subset of those of request mappings, the one that made any sense for us. And this is the final interface. So again, we're doing exactly the same, but this one, we are using the new Spring's own interface client. We will use post exchange because you can have HTTP exchange, but then also more specialized type, so post exchange, get exchange, etc. You can specify your path, and then we pass the request body. So this is pretty self-explanatory. And we actually use web client underneath, so that would be non-blocking communication. However, you can tell us that you want it blocked just by specifying a type that is not reactive in your return, and we will get this reactive response, but we will block it for you. So you don't need to take care of this. A lot of time at the beginning while switching to web client, teams struggle with this kind of new model of programming. So if you want to make it easier, you keep this web client-based communication, but then we handle it for you and we can return a single object. But if you just add a mono or a flux, you can be also getting reactive types. From us, we can also return a response entity, so you can get your status, headers, and body from it. And if you only need headers, that can also be done. And obviously, you can only execute if that's your scenario. How do you use it? The main question. So in order to use this, you just need to create a bin of HTTP service proxy factory. As you can see, these are roughly 2 lines of code. You need a web client. So how you build that web client, that's up to you. You would create it same as you create your web client for other, generally for that communication. So if you have certain URL, you would pass it. If you have any additional configuration, you would pass it as well. You could also add the load balancing filter, which we will see in the demo. And then we provide the builder method in the HTTP service proxy factory. So you just pass this web client instance via an adapter, again with a static method, so as easy as it gets. We've added the adapter layer to potentially be able in the future to also support other clients. For now, we just support web client, but there is this possibility. And then once you have this service proxy factory, you can create the client, just calling the method create client and passing the interface reference. And you can then return it as a bin if you wish to, or you can just create it in your class. Anyway, will work. So that's what we're going to see, the same demo as before, but we will now be using Spring interface clients. And I have also added the load balancer filter to show you how it works together. And as web client will now have this Spring observability support, you will get it out of the box without having to add any additional libraries. So let's take a look. Let me switch this off. OK, this is virtually the same app, just the interface client is based on the Spring client this time. So here it is with the post exchange. And in the application class, just to make it easier for the demo, I haven't added a different configuration class, but we are just creating these 2 bins. And then in the registration service, we can just call it. So that's here injected for us. So let's run this application. And one more thing I really wanted to show is that we have injected here the load balanced exchange filter function. And just by adding it to the filter of our web client builder, we are able to pass this base URL, which, as you can see, is not a normal URL. So it's not any reasonable host. There's no port or nothing. We are actually passing in this first segment here a service ID. And if we have services registered with this ID in Eureka or passed through the simple discovery client, as I have here in properties, so I am indicating that for service with this ID, I can handle various instances, in this case 1, but could have many. This will be handled for us under the hood, so we don't need to do anything much. So now let's try to run some requests. As you see, it passes. OK, let's switch both of these off. And let's go back to the presentation. And this presentation was given by Rosen, Stoyanchev, and me before. And actually, previously, that's where it ended, because that's what we had. But since then, changes were made. And now also the RSocket interface client has been made available. And it works very similar to the HTTP one. So if you know how one works, the other one is just has a flat learning curve, basically. You use the RSocket exchange annotation instead of HTTP exchange. And in that annotation, you have slightly different attributes. So here we have just one attribute that allows you to pass the destination that can be with AntPath matcher or with the path pattern, depending how you will configure an underlying RSocket requester. Because as the HTTP interface client uses a web client underneath, so you need to create it somewhere and pass it on. For this RSocket interface client, we are using the RSocket requester. So if anyone has worked with RSocket on the client side before, probably has used that. And now we would just pass it to the RSocket proxy factory. So here we specify this destination, and then there are various things that we can pass in our parameters. So we have a destination variable, which can be a concrete value, but can also be publisher. And here we can actually specify values that will be used if we have a templated destination. So if in our destination that we provide in the attribute of the RSocket Exchange, we have templates, we can pass the values with the destination variable annotation to actually build that URI. And then obviously we need a payload, and it again can be a concrete value or can be a publisher. And another thing that you can pass is an object followed by a MIME type. So those will only work in conjunction. If you pass an object and then a MIME type, it means that the object is a metadata entry, and a MIME type has to be an appropriate type for that metadata entry. When it comes to the return values, again, you can have concrete values or a producer. And yeah, that's as complicated as it gets, pretty much. That's how you create your interface. Here we are going to be seeing in the demo the same services doing exactly the same thing, but they will just be communicating over RSocket instead of HTTP. And again, we can return a blocked value for you, or a reactive type, which makes full sense with RSocket. And then to create it, it's virtually the same. You just need a different factory. So RSocket service proxy factory, and then you create an RSocket requester. You have to configure it as you need. Here I have just passed that I want to communicate with an RSocket running on TCP on localhost on 7000. But obviously, you might have some strategies, for example, for decoding and encoding, for reconnects. So you can configure it as you would normally, and then pass it to the factory. And then, again, we just use that factory to create a client. Let's take a look at that. Okay, so the only difference in the verification application is that we have added starter RSocket instead of web flags starter. And then in our controller, we don't have REST controller annotation, just the normal controller. And here we have just a message mapping with a destination, and since we've added RSocket starter to our dependencies, it will be running an RSocket communication for us. And then on the client side, we also need that same starter, so it's exactly the same one. And I have also added web flags, but I've added web flags just because I will not be running RSocket communication from the console. I will be running an HTTP request just to enter here this point. But then once we are here in the application, this verification service client will further use RSocket to communicate with the other app. Here is the interface, and here are the beans. So for example, I need JSON to JSON encoding and decoding, so I have set it up for my requester. And obviously, you can do any additional config on the requester that you need. I have the factory now. Now I just need to call the create client method, pass this interface class. I have my method with annotations, so we know that we'll be calling this verify destination, and we will be passing this object as our payload. And yes, we have some additional setup and properties, but as you see, not much really, and we can already communicate. So let's run this application. Okay, first let's run the other one. And that's exactly the same call we need to do. And as you see, with just very minimal changes, we have switched our application from OpenFeign to the Spring interface client, and then from Spring HTTP interface client to Spring RSocket interface client, just by tweaking a few annotations. And it all works. You can see the communication logs here from the deserialization. Yes, and going back to the presentation, this is what I've had for today. I have linked, I'm going to share it with you through the organizers. So I have linked all the demo code repos and also all the projects I have talked about. And please use it, and yeah, let us know what you think, or create issues if you like something, or PRs. We are very interested to see how the community is going to receive these new interface clients. Thank you.